All right. So let's take a look at winning an auction. This demonstrates a simple attack in Solidity. So here, make a new contract called auction here. And I think I've already added that to my remix. So if I go back to the icon showing two pieces of paper here so I can see my contracts, here's the auction. All right, so what this auction does, all right. What the auction does is it lets you send money up. And when you send money up with a bid.
Oh, no. If you're walking or driving.
That one. All right. When you send money up with a bid, it will accept that money and it will turn you into the highest bid when you bid. But notice what happens here. It requires that if you send it money, you must send it more money than the current highest bid. And if that happens, it has to refund the previous bid to the previous person. So the way this works is you have to give it your money to make a bid. And then if somebody makes a higher bid, the first thing it will do is return the previous highest bid's money back to that person. And then the new person becomes the leader and their bid becomes the highest bid. This require statement, I think the same thing you'll see in other languages, this condition must be true or it will cancel the transaction. So it returns the money it's holding from the previous highest bid. That's the auction. Now we've got an attacker contract here too, but I'll talk about that later. So you compile the auction. And I think we're going to deploy this one on a local JavaScript machine. Let me take a look. Yep, we're going to put it on a local JavaScript simulated blockchain. That's good. That's faster and easier than MetaMask. So we go to compile, or go to deploy rather, and move it to the JavaScript VM. All right. And you can see this is a fresh blockchain with a bunch of accounts that each start with 100 Ether. Now I can deploy, there are two contracts, the attacker and auction. The one I want to deploy is the ordinary auction. So I deploy it. That performs a transaction. The green check mark tells me it worked. And you can see I spent a tiny amount of money here. I'm a little bit less than 100 Ether now in the account I used to deploy it. And now I have some things I can do here. I can bid, I can view the current leader, and I can view the highest bid. So this account has almost 100 Ether. I'm going to bid 1 Ether. I put in 1 Ether to be accompanied, and I hit bid. That sends a transaction. It mines it and gives me a green check mark. So it was processed. Now my money has fallen down to 99 Ether, slightly under 99. So my 1 Ether went away. And if I view the current leader, it shows me an address starting with 5B. So if I go up here, that's me. That's the account I used to send in 1 Ether. So I am now the leader. And the highest bid is 1 followed by 18 zeros. So this is 1 Ether. So that's working as expected. I've made a bid. Now, if I take the second account and make a higher bid here, this account has 200 Ether. I'm going to send 2 Ether in as a bid from that account. So the transaction succeeded. I got the green check mark. So now the current leader is AB, and the highest bid is 2 Ether. And this AB should be the address I just bid from, which it is. And if you go back to the first account, they're back to almost 100 because their 1 Ether was sent back to them minus gas fees. So it's working. That's the auction running as intended. Now we're going to attack it. And the attack is incredibly simple. Here is the attacking contract. You can send money through the attacking contract with this win function. It will take money that comes in and it will then call bid on that money. That's all it does. But the magic is here. There's a fallback function. If you send money to this address, it's not a wallet, it's a contract. And when money comes in to a contract and you don't specify what function you're calling, it uses the default function fallback. and the fallback function reverts. So this contract cannot receive money. If you try to send any money to this contract, it refuses to accept it and cancels the transaction. And that means I will always win, as you'll see. So now, if I take the third account here, and I want to make a bid of 3 Ether. Now, if I use the bid here, I'm going to be participating normally, not hacking in. I have to use my attack contract, which is here. So I have to deploy it. Now, when you deploy the attack contract has to call a second contract, the auction. So it needs to know the address of the auction. So I have to go down here and get the address of the auction and put it here. So the attacking contract knows which contract it's trying to attack. Now I can deploy that one, and the transaction succeeds. And now I have a second contract here called attacker. All right. And oops, looks like I accidentally sent 3 Ether when deploying the contract, which was not very sensible. But anyway, I'm not going to worry about that. I wanted to make a bid of 3 Ethers here. So 3 Ether. All right. Let's attack from the 4th contract, just so I start with a nice clean 100 Ether. So the 4th attack is going to send 3 Ether down here to win. The transaction succeeds. Now the highest bid is 3 Ether, and the current leader is address 9EC, which is this. All right. That's right. I remember it's not any of these accounts because I passed it through my contract. The current winner is this address, 9EC, the attacker contract. So the point is I've now bid 3 Ether and I'm going to win the auction, because if anybody tries to bid higher, like if I go back to say the first contract and they try to overbid me with 4 Ether, it's not going to work. When they try to bid 4 Ether, the transaction is going to fail and be reverted, because when it tried to return my 3 Ether to me, I refused to accept it. And because this had the require here to send it back, it couldn't proceed to make them the leader or make them the highest bid. So even though these person bid 4 Ether, the leader remained the same and the highest bid remained the same. So I've jammed up the system. And that's this simple logical flaw of this contract. So you can cheat. Now, you can fix it, by the way. So there's a flag defined by seeing the result of bidding higher. To fix it, you can just refund the old leader, but get rid of the require. So it attempts to refund the old bid, but if the refund fails, it continues and lets the next person win. That is one way to fix it. It's just a simple logic flaw in your contract. All right.